Back to another video, guys. You're on A-level maths and we are going to consider quadratic functions and their graphs. So we're going to go through exam style questions, and actually in the case if you forgot the basics about quadratic functions, it's right time to go and refresh your knowledge, assume knowledge, I may say, and you can watch the crash course from GCSE where I consider everything related to quadratic functions. Actually, it cover part of A-level program. However, the problem is going to be for A-level maths, and let's have a look there. So pause the video, try to do it by your own, and we start solving that. So you're given data x, y coordinates for points, several points, 1, 2, 3, 4, 5, 6. There are 6 points which lie on the parabola y-x. Here is the graph. This is precise graph. However, you are not given any grid lines for precise values. So in other words, you cannot get the precise value for any given x coordinate, what it corresponds to, which y value corresponds to that. So, but you know that quadratic function has a minimum at x equals negative 1.56. So you need to define y value when x is negative 274. Okay, I'll give you 2 ways how you can solve that. The first is classical way, is about quadratic equations, okay? And the second way is more optimized, and I recommend to use that. So that's why I start from the shortcuts, from the easiest way, how you can define, then we just go to classical way, how you can do, if in case if you can, if you cannot get how you can do in the easiest way. All right, so let's start from the easiest way, and let's have a look first at the x corresponding to the minimum value. So what does mean the minimum value? It means that the axis of symmetry definitely will go through this x coordinates. So that's why the equation of the line of symmetry is going to be x equals to negative 1.56. So this is the line of symmetry. Okay, symmetry line. And there is the smart way how you can find the y value corresponding to x, which has negative 274. First, you can estimate around, but finally you need to give the precise value. So let's assume that this is 3. So somewhere here, that's going to be x equals to negative 274. Okay, so that's your value where you're supposed to define. And if you put the vertical line, so it's better to use that, not dashed line. So you will find approximate value for y, okay? So y coordinates of that point. So here is your point, and the approximate value is going to be somewhere 1.5, 1.6. So 1.5, 1.6. So this is y approximate value, okay? From 1.5 to 1.6. Okay. But you're given values. If you have a look at your data set, you're given for x from 0 to negative 0.6, so 0.67. So it's somewhere here, okay, within this range. So the idea is you're trying to guess, okay, if you're given that table, obviously you can find corresponding point that lies on the same level, for example, right there. And this is going to be the same y level for the point that you are going to define. And what if you can find this value from your table? Okay, so obviously your values might be from that, let's say from this to that y values, because we estimated around 1.5, 1.6. So somewhere here. And you can guess, so that might be 1.69, 1.52, 1.48. So what if you can get the precise value for x. Okay? So this is going to be precise value for x. That will have the same distance. So I'll just drop the distance here. And I'm going to say that the distance from that point that we established, negative 274, that's our target point, it's right there, to the line of symmetry will be equivalent to the distance from the line of symmetry from there up to some x coordinates, which are might be 1.69 or 1.52 or 1.48, because you're given the data table, so maybe that's intentionally so that you can pick corresponding value. Okay, how to find this value now? Okay, so how to find? You simply know that this distance we can mark as delta x, and simply can be calculated as, let's say, just erase a little bit. Okay, this distance can be calculated as the difference between your coordinate, absolute distance, negative 274, and you take away minus 1.56. That's how you can get the distance, okay? You take an absolute. If you calculate delta x, you'll get, let me see, if you subtract, you'll get 1.18. So this segment is going to be 1.18. So obviously, this segment will have the same value. So this width is going to be the same value, okay? So that means if you take away from the value x equals negative 156, this distance, so you're adding absolutely in order to get this point x. So right now we are going to define that x point, x coordinate of that point, and we will have the following. So we taken from the symmetry line, x coordinates 156. We are actually adding, because it's negative, so we add in this distance 118, and if you do that, let's calculate. So 156 and 118, we'll get 038, and we exactly have, sorry, with the minus sign, and we exactly have this value, negative 038, and we exactly have this value in the table. So hopefully we can establish the final y value, so to be 148, and this is solution. So that's the fast track. So y corresponding to x equals negative 038, or to the x equals negative 274. It doesn't matter because the parabola is symmetrical around your line of symmetry. It means y value will be the same. You'll get negative, you'll get 1.48, and this is the final result. Okay, that was the fast track. What if you were confused and that wasn't really obvious from the very beginning, right? So you can go and try to use the general way or general approach. So look, you have the parabola that definitely goes through y-intercept. So y-intercept equals to 2. So that's why, what if you just arrange the general form of quadratic equation with c coefficient to be y-intercept? In your case, you're given definitely when x is 0, your y-intercept is 2. So that's why c equals to 2, you know y-intercept. So the idea is to find coefficient, find a, b, and c, and establish their equation. You can just plug x equals negative 274 into equation of the parabola if you find all the coefficient, and that's how you can get y value, okay, y value corresponding to that x coordinates. So that's the straightforward and classical way. So we already know c equals 2, and what we can do, because we have plenty of points, we can take any random points and complete the equation in order to find coefficients. Because there are two coefficients left, a and b, we need to plug two set of points. For example, we can take, for example, that one, and let's take this one, okay? So we just plug those points and say, okay, if we plug negative 0.32, we'll get y equals 152. And everywhere, instead of x, we plug in negative 0.35. Here this is going to be squared. So bx is going to be negative 0.35b. And c is 2, so that's why plus c, okay? That's the first equation where we have coefficient a and b. And the second equation, we plug in negative 0.38. So we'll get 148 equals to, again, a times. Now we plug in negative 0.38. We square this up. We have the same x value times b and plus 2. Okay, so what we can do, we can actually solve as the system of equations. And this is the fast track how you can solve that. So you just simplify, you have two unknowns. Okay, you have two unknowns. You just solve and find a and b coefficients. So, or you can use your GDC. So GDC is the best way, system solver, so solver or equation solver, and try to input coefficients before variables. Your variables are a and b, and that's how you can solve that. Okay, assume we solved that. We found all the values a and b, and what I found, a is going to be 0.5, and b is going to be 156. On top of that, you can actually use a bit another way, because you know that x vertex for the line of symmetry is going to be negative 1.56. Instead of plugging the second value from the table, yes, you can actually, for example, if you're given only one value, x and y, only one single point, in this case, you can use probably the vertex coordinates. And just remember that in case x vertex is negative b over 2a, just remember the formula for the vertex, and you know that the result should be negative 1.56, where you can connect a and b. So from there, you can definitely connect that b is going to be 2 times 1.56 and times a, okay? So it's going to be 2 times 156 and times a. So that's why you can actually find, so express b through a, plug into the very first equation right there, and that's how you can find a value, if you like. Okay, so nevertheless, if we found a, b, and on top of that, we already knew c, so the general equation y from x, I just drop here, is going to have the following form. So 0.5x squared, then we add 156 x and plus 2. So that's the equation for the quadratic function. And what we can do, we can plug the value y from negative 274. Negative 274. And if we plug that and calculate, we'll get the value corresponding to that x value, and the final result is going to be 1.48. So this is a bit longer way, but it's a classical way, and you can always apply no matter which sort of problem you will have, okay? That was a short problem, but I explored and investigated several approaches, so please, you're welcome to use any one. If you understand how the first works, no problem. That's actually pretty simple. There is no like hard, there is no like any difficulties with that, because you definitely know that you can grab another value from that table. But in case, what if it's impossible, right? For example, you calculated that x and it wasn't any of those values given in the table. So in this case, you need to switch to classical approach and continue with that. So hope you like that. If you're new here, don't forget to subscribe. Don't forget to smash that bell button in order to be notified about daily updates. And don't forget to visit Zillion's A-level classes for more information. Thank you guys, and see you next time.